So I think all mics are muted. Okay, so today we're going to do a chapter 1, physical quantities and measurement. So physical quantity is defined as a quantity which can be measured. So the quantity that we can measure, we can use a value to represent it, then we call it physical quantity. So there are two different types of a quantity, which we call it basic or base quantity. Both of them, they refers to the same thing. It is the most fundamental quantity that cannot be derived from any other quantities. Okay, if it can be derived, then it is not basic quantity. And then another one is what we call derived quantity, which we derive it from basic quantity. Now, how are we going to derive it then? Then we use a method called dimensional analysis. Okay, dimensional analysis. So dimension is defined as a technique or a method which physical quantity can be expressed in terms of combinations of basic quantity. So you combine different basic quantity and then it will becomes a uh, derived quantity. So it can be written as, okay, so after you derive it, it can be written as a physical quantity. Okay, so this is how we write it down. So you put a square bracket and then this is your physical quantity. Okay, you write the name, the physical quantity name, for example, velocity. Or you can write it in the form of the symbol. Okay, the symbol. So symbol of dimension, not symbol of unit. Okay, so make sure you know what is the difference between the symbol of dimension or the symbol of unit. Now, why dimensional analysis is important? Other than you can use it to derive quantity, it can also tells you when a relationship is wrong. Now remember, it can only tell you whether the relationship is wrong or not. It cannot tell you whether it is correct or not. All right, so you will learn that in your tutorial class, how to use it to check whether a relationship is wrong. All right, remember, it can only check if it is wrong. All right, it cannot prove that a relationship is correct, a quantity is correct. So now let's look at the table. So the table shows us the dimensions of a basic quantity. So we need to derive quantity, but before that, we need to know what is the basic quantity. Okay, so the symbol. Now the first symbol, it represents the symbol in dimension. Okay, the symbol in terms of dimension. And then the second symbol is a symbol of unit. So symbol of dimension, okay, for mass, okay, is capital letter M. Okay, capital letter M, and then length is capital letter L, time is a capital letter T, electric current capital letter I, and then temperature is a theta, amount of substance is a capital letter N, and then luminous intensity is a capital letter J. Right? So these are the symbols that you're going to use in the dimensional analysis. Whereas the symbol for unit, kilogram, you know, is a kg. And then meter is a small letter m, times second in terms of S. And then electric current, the unit is capital letter A. Temperature, okay, temperature, the SI unit is Kelvin. Okay, it's not degree C. This is a very common sin misconceptions among students. All right, remember, temperature, the SI unit is Kelvin. And then for amounts of substance is a mole. Okay, and then luminous intensity is a candela. So your symbol is a CD. So now let's look at an example, how to apply this, okay, how to use a dimensional analysis with all this symbol. Now, for example, you have a velocity. Okay, now you want to derive the unit for velocity. So what are you going to do? So you want to derive, you want to do dimensional analysis, right? Then you have to tell the reader, now what are you going to do? You want to derive the dimension. So you put a square bracket here. Square bracket means now you're not going to calculate the values of velocity, but instead of that, you're going to do the dimensional analysis. You want to derive its new quantity. You want to check the relationship. So velocity is equals to, okay, square bracket again, displacement, Okay, so displacement is the types of length. So you put it in the bracket over time. Okay, so the equations, you put it in the square bracket. Okay, you put it in a square bracket. And then you then change it into its symbol. So the symbol for velocity is V. So a square bracket represents that you're still doing the dimensional analysis. You're still checking the relationship. So change of displacement, okay, change in displacement is a del S, okay, or you can just write S, I suppose it's a okay. And then the change in the time, so del T. And now, okay, now that you have it in equations already, next step, you use the dimension symbol, okay, the dimensions of a basic quantity symbol to replace the displacement and the times in the equations. So del square bracket V is equals to, now, displacement is a type of length. Length, the symbol is capital letter L. So you put an L here. And then over time. So time, the symbol is capital letter T. Okay, capital letter T. Therefore, the dimensions for V velocity is LT negative 1. So from this LT negative 1, you can then get the unit for V. Okay, so unit for V for velocity is very simple. So you go back to the table again. L is length. Length, the unit is meter. So meter, the symbol is M. So unit is M. And then capital letter T, okay, is the time. Times the unit is a second. Second, the unit is a S, small letter S. Therefore, you just replace LT with MS negative 1. So this is how you do dimensional analysis, and this is how you use this table. Okay, you use this table. You start from equations, and then you put a square bracket to indicate that now you're going to do the dimensional analysis. Now you're going to check the relationship. So from a square bracket, from the equations, you then transform into the symbol in dimension, okay, which is this column, right? So symbol in dimension. So from symbol in dimensions, you simplify the equation. So the example given here is very simple. You don't have to do any simplification. But in an exam, sometimes you have something more complicated. So for example, if the question asks you to derive the dimension for force. So force equals to acceleration times. Acceleration equals to velocity over time. Velocity equals to displacement over time. So you have to do it step by step until you get the final answer, until you reach the final answer where you can get the unit in terms of SI, base quantity, okay, SI unit. So this is a unit, all right? So derived quantity, you can use it to derive the SI unit for any quantity, any physical quantity. All right, so that is a dimension. So we're done with the first part. Now we're going to look at scalar and vector. Okay, scalar and vector, the main difference is in the definition. Scalar quantity, it shows you the magnitude only. The direction is not important. So for example, if you're looking at distance, so distance, it tells you, okay, now the distance between two objects is 10 cm. 10 cm is just a value without direction. Okay, so in that case, we call it scalar quantity. So example given here is say a car moved for 30 km. So it just moved for 30 km. It doesn't tell you what is the direction. So in that case, we know that this is a scalar quantity. Okay, so it is you can calculate it by using the ordinary algebra. So you can just simply add it. Okay, do the additions, multiplications, subtractions, or division. Okay, without thinking about its direction, without looking at its direction, because it's not important. So if you're given two scalar quantity, you just add them up. Okay, for example, you're given 230 km, you don't have to think whether you're going to add them or subtract them. If the question asks you to calculate total, then you add it. If the question asks you to calculate the difference, you subtract it. Don't have to think about the direction. But when it comes to vector quantity, then it's different because you have to think of its direction. So if object is moving in different direction, then what are you going to do? You are going to proceed to the next step called resolving vector. Okay, it is something that you're going to learn in your tutorial as well. So you are going to resolve it, and if the question asks you to calculate the total of a vector or the changes in the vector, then you're going to proceed the next step called resultant vector. Okay, resultant vector. You're going to do addition or subtraction in terms of vector by using the method in vector. So when it comes to a vector quantity, you have to look at its direction. If object is moving towards same direction, for example, now I have two vector A and vector B. Question asks you to calculate total, then you can straight away use vector A plus vector B. Okay, if you have two vector, for example, A is going to the right and B is going to the left, then question asks you to calculate the total. Now, of course, total, you're just going to add them up, right? So A plus, but now B is going to the left. You have to think about its direction. It's moving towards different direction, towards opposite direction. So in that case, we say negative B. Okay, negative B. So if object is moving towards opposite direction, then our operation will become a subtractions operations. Okay, so A minus B. So this is the example. Okay, same direction, you can straight away add them up. Different direction, then it will become a subtraction. Now, if they are moving towards a different direction at an angle, so for example, now you have A towards this direction, and then B towards here. And question asks you to calculate the total of these two vectors. So what are you going to do? Then you have to proceed to something known as resolving vector. So you resolve them so that these two vectors, they can lie on the same plane, same component, before you add them up. Right? So that is the main difference between scalar quantity and vector quantity. Scalar quantity, you don't have to think about anything. You straight away add them up. Okay, you straight away do anything that is told in the question. And then vector quantity, you have to think. What is the directions? Are they lying on the same component? Are they pointing towards the same direction? If no, what should you do? If yes, then what can you do? All right. So vector quantity is stressed a lot in a direction. So if a question asks you to solve something that is related to vector quantity, for example, the question asks you to calculate displacement of an object. If it uses the term displacement, then other than the magnitude, the value, you have to state the direction in your final answer. All right, because you are looking at vector quantity. So when it comes to vector quantity, the direction, it's very important. Okay, even though the question just say displacement, but you have to mention the direction. Okay, you have to state the direction in your final answer. Okay, now, what is the things that we can use to describe direction? Okay, now, first is the directions of a compass. Okay, the directions of a compass. Let me show you here. So that is the first thing. Okay, directions of compass. We can use it to represent the direction. So for example, north, east, south, west. So all these we can use it to represent directions. And then the second things we can use angle. Okay, we can use angle. So for example, 50-degree above positive x component. Okay, positive x axis. So or a 50-degree above a horizontal line. Okay, and then the next thing is a Cartesian coordinate. Okay, this is also another method where we can use to describe its location. So x is let's say x is located at 5 meters from the origin, and then y is 10 meters from the origin, for example. Okay, and then another one we seldom use is the polar coordinates. Okay, so this one you just know the name. And then the last one that we can use is a sign. Okay, we use sign to represent it. So for example, if object is going to the right hand side, we use positive sign. Left hand side, we use negative sign. Going up, we use positive sign. Going down, we use negative sign. So sign can be used to represent a direction as well. So there are 5 methods that can be used in our questions in our vector quantity together with our vector quantity to show its direction. Okay, so next, illustrate the unit vector in terms of Cartesian coordinate. So now you have something, okay, in 2 dimensions or 3 dimensions. So unit vector, we are going to use unit vector to represent it. So unit vector is a vector with magnitude of 1. Okay, for magnitude of 1. So it is dimensionless. Now, dimensionless means no unique. Okay, so the no unique, sometimes question will say, we just use the term dimensionless. So it means no unique. Okay, and it is always parallel to the coordinate axis. So unit vector is used for pointing and showing direction. And the unit vector notation, we use I, J, and K with a hat. Okay, hat is a something that looks like this. Okay, this is hat. So I, and then this is J with a hat, and then this is K with a hat. So unit vector, they are dimensionless, okay, as shown, as I told you just now, because it has no unique. And unique, wait, yeah, the screen is moving, I'm not, yes. All right, it's moving. So unit vector is dimensionless, and the vector can be written in terms of unit vector as a R. So now, for example, if you have a vector here, okay, this is your vector R. So how are we going to use a unit vector to represent it? So you use R equals to Rxi. So you calculate the value along X component. So this is the value. You look at the value Rx, and then you look at the value R along the Y component, and then the values along the Z component. Okay, and then you use ijk to tell the reader the value given is along X component, Y component, or Z component. Okay, so for example, now you have okay, look at the table below here. Now you have a vector in 2 dimensions. So how are you going to use unit vector to represent this vector? Okay, to represent this vector. So the value along X axis is 3. Okay, this is along X axis. The value along Y axis is 4. So when you want to write it in terms of unit vector, then it becomes 3i plus 4j. Okay, 3i plus 4j. So from coordinates, you change it into unit vector. So this is the unit vector form. So if question asks you to write something in the form of unit vector, you calculate the value along X axis first. Okay, in terms of X component, and then you resolve the vector into Y component. Okay, sometimes you are not given coordinate, but you are given a value, a vector, then you have to resolve it. After you resolve it, you use unit vector to represent it. You use I and J if you are given a question in 2 dimensions, but if you are given a question in 3 dimensions, then you have to add in one more K. So example given here, now you have the P. The coordinate for P is 2, 3, 5, where 2 is the value along X axis, 3 is the value along Y axis, and 5 is the value along Z axis. Then when you write it in a unit vector, then you have a 2i, 3j, and 5k. Okay, 2i, 3j, and 5k. So this is in the form of unit vector. So basically, it's quite similar to your coordinate. Okay, just that now you're using a different method to show your answer. Okay, to show your answer. So another example that I mentioned just now, sometimes you're just given X and Y component, and then questions give you a vector. For example, now this is vector P equals to 5 Newton. Question asks you to use a unit vector to represent this vector P. Okay, to represent this vector P. So how we're going to do, you resolve it. So for example, given angle 20 degree. So you resolve it into X component. Okay, so for example, now you have a value called A, and then you represent it in, you resolve it into Y component, you have another value B. Then you use unit vector to represent it. So P is equals to AI plus BJ. Okay, so if you are given a vector, if you are given a value, so you have to do resolving vector first. If you are given a coordinate, then straight away you can use unit vector to represent the vector. Okay, you can write it in the form of unit vector. All right. So if you have any questions, you can just switch on your mic and ask them. Yeah.
Kan yang tadi ada graf 3 dimension.
Ada graf apa?
Yang ni apa satah tu 3 dimension.
Aha.
Z memang ke atas lah. Memang bentuk dia.
Actually yang XYZ punya locations biasanya kita tentukan sendiri lah, tak semestinya kena ikut dia. Okay, tapi kalau soalan bagi, memang dia akan bagi dalam bentuk ini. Okay, X di sini, Y di sini, Z di sini. Tapi kadang-kala kamu akan nampak mungkin X di tepi, Y di depan. So, dia terpulang pada macam mana soalan bagi anda.
Okay.
Okay. Okay, so yeah, this is your versions. Your version is blank. Okay, so make sure you add in the equation. So equation just now, I think it's not in your books, right? So you write it down. Okay, buku tadi yang equations ini tak ada dalam buku anda. Alright, so next. Okay, so state the physical meanings of a dot product and a cross product. Now, it just wants you to state the physical meaning. In your syllabus, it doesn't ask you to calculate. Okay, but it will be better if you know a bit of a calculation. For example, what happens when you have a 0 degree? What happens when you have 180 degree? What happens when you have a 90 degree? Okay, so 0, 90, and 180, they are a very special case. Okay, they are a very special case where you have to know what happened. Okay, so now dot product. So dot product, the physical meaning, okay, it can be defined as vector A dot vector B equals to AB cos theta. Okay, AB cos theta. So the dot product is a scalar quantity. Okay, that's why it also known as a scalar product. And A and B must be parallel to each other. So what happens if they are not parallel to each other? Then you have to resolve it. And that is one of the reasons why you obtain cos theta in your definition. So now let's look at this example. Consider the two vector A and B, they're lying on the same plane as shown in the diagram. Okay, now vector A and vector B, the one in the black color, they are pointing towards different direction. They are not parallel to each other. So if you want to apply scalar quantities, the scalar product, the dot product, then you have to make them parallel to each other. So you have to resolve either one. Okay, either you resolve B or either you resolve A. So in this case, in the examples given, it resolves A into B. Okay, it resolves A so that it's pointing towards the X direction. So after you resolve A, you are going to obtain AX equals to A cos theta. Because angle is located beside x-axis, so we use the cos functions here. Okay, so AX is equals to A cos theta. So what are we doing here is actually we use AX multiplied with B. Okay, therefore we have AB cos theta. So the reasons why we have this cos theta, it is because we resolve the vector. We want to make sure they are parallel to each other. Now, if given the case where they are already parallel to each other, then straight away you are going to get cos equals to 0. Okay, and what happens when cos equals to 0 means that you're going to have a maximum value. Okay, you're going to have a maximum value. So let's see whether they mention it here. No. So now if you have a two vector, they are parallel to each other. So if this is your vector A and this is your vector B, so it means theta is equals to 0 degree. So when you have a cos 0 degree, it is equals to 1. So in this case, it will give you the maximum value of a scalar product, of a dot product. Okay, so if the angle between A and B, okay, if the angle between A and B is 90 degree, okay, if angle between them is equals to 90 degree, then you are going to get a minimum value of a scalar product in which it is equals to 0. Why? Because cos 90 is equals to 0 degree. Is equal to 0. Okay, cos 90 degree is equals to 0. So you have to know these two cases. It is very important, especially when it comes to objective questions or your UPS questions. All right, because sometimes it will ask you, what is the maximum value of a scalar product? What is the minimum value in a scalar product? Okay, or which angle will give you maximum value? Which angle will give you a minimum value? So this is how you determine it. So whenever you have a functions and equations that come with a trigo function, the way we use to determine maximum or minimum value is the angle. Cos 0 degree give you 1, cos 90 degree give you 0. All right. So yeah, this is another example. If you resolve B, so if you resolve B, it's also B cos theta. You make B parallel to A. So eventually, you're still going to get AB cos theta in your calculation, right? So that this is the conclusions. Okay, this is a summary. So it doesn't matter whether you resolve A or you resolve B, you are going to get the same answer, which is AB cos theta. Okay, which is AB cos theta. So one of the example is a work done by a constant force. Okay, this is the equations that you're going to see in chapter 5. So W equals to F dot S, which is equals to Fs cos theta. B equals to F dot V, okay, or power, so FV cos theta. So whenever you have a dot product, okay, then you are going to change it into a cos theta function. So don't get confused between multiplication and dot product. Okay, so I know sometimes in mathematics, you like to use, for example, A dot B means A times B. In physics, when it comes to vector, this one represents dot product. Okay, so when you have a vector, means you have a quantity with an arrow on top of it, then it is a dot product. Okay, it is a dot product. So vector with a dot in between them represent dot product. But in mathematics, okay, if it's not vector, if you just have two alphabet, then it is a multiplication. Okay, now let's look at cross product. So cross product is defined as, okay, now it's defined as what? It's defined as A, vector A cross vector B equals to vector C. Okay, vector A cross vector B equals to vector C. So it can be written as, or the magnitude can be written as, now when you want to calculate magnitude, you put modulus beside the vector. Okay, you put modulus. So modulus of vector A cross vector B, okay, which is equals to modulus of vector C. Okay, it's equals to A B sine theta. Okay, A B sine theta. So this is the definitions of cross product. Okay, the definitions of a cross product. Okay, so let's see. So I'm not going to show you how to derive it because it is slightly more complicated. Okay, so now what are we going to see? Since you're looking at a cross product, a vector product, then it will have a vector quantity. Okay, the products, the result of a cross product is a vector quantity. The result of a dot product is a scalar quantity. So dot product, you don't have to look at the direction. But when it comes to a cross product, okay, other than the magnitude, you also have to know how to determine its direction. Okay, so magnitude can be calculated by using AB sine theta, and then the direction, you can use your right hand to find the direction. Now, when it comes to cross product, the angles between C and B, and also in between C and A, they are always perpendicular to each other. Okay, but A and B, they don't have to perpendicular to each other. All right, so A and B, the angle between them is there's no rules, there's no limit. Okay, it could be start from maybe 1 degree until 359 degree in between A and B. But C is always perpendicular to the both of them. Okay, C sentiasa perpendicular to vector A dengan vector B. So now when you have vector A and vector B, okay, you use your right hand to determine the directions of C. Now you point your 4 fingers towards direction A. Okay, before you curl your fingers. Sebelum kamu tutup kamu punya tapak tangan, okay, 4 jari menghala ke arah A. Okay, the 4 finger you point it towards the directions of A, and then your finger you curl towards direction B. Okay, tutup jari kamu ke arah B. And then your thumb, ibu jari, represent direction C. Okay, so if you are given a vector A here, okay, so you point 4 fingers toward A first, okay, and then you close your fingers, you curl your fingers towards directions of B. So direction C represent the results, okay, the directions of the result of the vector quantity. So this is for the case A cross B. Now, if you have a case where it says B cross A, it mentioned B first, then you start from pointing your 4 fingers towards B. Okay, your 4 fingers. Okay, you point it towards B, and then you close your hand, you curl your fingers towards the directions of A. Okay, you curl it towards directions of A. Then the thumbs represents the directions of the vector product. Okay, the results. Alright, buka 4 jari, point ke arah B. Sebab apa? Sebab sekarang equations sebut B dulu. Dia sebut B dulu, 4 jari point ke arah B. And then kamu punya tapak tangan nak tutup ke arah kanan ke atau kiri ke, dia terpulang pada arah A. Okay, so sekarang arah A di sini, kamu tutup jari kamu ke arah A. Okay, tutup jari kamu ke arah A. Dan kamu akan dapati C menghala ke bawah. Sebab apa? Sebab bila kamu tutup jari ke arah A, kamu punya finger, kamu punya thumb, ibu jari menghala ke bawah. Alright. So now let's try the other case. So if the question gives you B here, okay, and then your A is behind it. Alright. And then the question asks you to determine directions of C if you have B cross A. Okay, you have a B cross A equals to C. So where is your C now? All right, where is your C now? So what are you going to do? So you point your 4 fingers towards the directions of B. Okay, 4 fingers, 4 jari ke arah B. And then you curl it backwards, okay, towards direction A. You close your fingers. You will see that C is going up now. So even though you still have a B cross A, but now because the directions of A, the positions of A have switched to backwards, okay, instead of coming out from a page, it go into the page. So you close your fingers, you curl your fingers towards direction A. Okay, 4 fingers towards B, and then close it towards A. Okay, curl it towards A. So you're going to get a C going up. Okay, C pointing upwards. So this one, you try it until you can get the directions of C, all right? Because it's very hard to show you in a screen. So you have to try it until you get this 3 value, okay? Until you get these 3 results. So 1 is going up, 1 is going down, and then when you change the directions, the positions of A, you get the C going up again, right? So A and B, okay, they now you say must be perpendicular, but sometimes you get a question that is not perpendicular. Okay, so this is not a must. All right, for me, this is not a must. So if they are not, so you have to resolve them. Okay, so if you want to calculate, okay, that's why they say you have to resolve it. So A and B, in a calculation, they must be perpendicular to each other, but in terms of determining the direction, not necessary. Okay, calculation must be perpendicular. Determine direction, not necessary. Make sure you understand. So if they are not, then you have to resolve either one of them to make them perpendicular to each other. So consider now you have a 2 vector, A and B. They are lying on the same plane and they are not perpendicular to each other. So you resolve either one. Okay, you resolve A so that it's perpendicular to B. Just now we want parallel, now we want perpendicular. So it becomes A sine J. Okay, A sine J. So eventually you're going to get AB sine theta. Okay. So this is one of the example. This example we'll discuss it again. So example of a vector product is the turning effect of a top. Okay. So now you have an object, a disc that is rotating. Okay, that is rotating, and then you want to determine the directions of top. Now top, it tells you the tendency of an object to rotate. Okay, so it is a quantity that you're going to learn in chapter 8. So this one, I will leave it in chapter 8. I will discuss it with you again in chapter 8. Just that now you try to see how they use to determine the directions of top. Okay, top mungkin kamu tak tahu apa lagi, tapi at least kamu tahu macam mana nak tentukan arah dia. Okay, so top is equals to R cross F. This is the definitions of top. So R represent radius. Now radius, by right, it shouldn't have a directions, right? But we just take it as a direction from the origin towards the edge of the disc. Okay, towards the edge of the disc. So the 4 fingers, you point it towards the directions of R. Okay, from the origin, you put the 4 fingers, point the 4 finger from origin towards the edge of the disc. And then you look at the directions of rotation. So in this case, the disc is rotated in the anti-clockwise direction. So you curl your fingers towards anti-clockwise direction. And thumb represent the directions of top. So top is coming out from this. Okay, it's coming out from this. So if it curves in a clockwise direction, then the top will be going into the page. Okay, will be going into the other direction. So that is how you determine the direction. All right, that's how you determine the direction. So basically, these right-hand grip rules, okay, which is the rules that we use to determine the direction, it can be applied in any vector questions. Okay, any questions that you need to use vector, you need to apply the vector in the equation. So you look at the equation, right? Always look at the equation. So the first vector represents the directions of 4 fingers. Okay, 4 fingers. And then the second vector, it tells you where to curl your fingers. Okay, so you curl your fingers toward the second vector. And then you're going to get the result, okay, which thumb. The directions of thumb represent the directions of the result of the top. All right. So that marks the end of chapter 1. Okay, that marks the end of chapter 1. Now I give you 2 minutes break if you have any questions that you would like to ask before we proceed to the first part of chapter 2. Okay, kalau ada sebarang pertanyaan, part yang kamu tak faham, anda boleh tanya sekarang. Kalau tidak, kita rehat 2 minit sebelum kita sambung ke part pertama chapter 2. Good, so far so good, no question. Okay, now let us continue. Okay, I'm not going to proceed to the notes in your your lecture notes yet. Okay, I'm just going to do a bit of revision with you guys to make sure you understand the difference between in a scalar and vector. Okay, because it's very important in this chapter. Okay, especially you have to know all this term. Okay, the terms that represents vector quantity, the terms that represents scalar quantity. So this is just a revision that is not in your handout. So you just pay attention, make sure you have a concept. Okay, make sure you understand. So there are two aspects to any motions. Kinematic is deal with the concept that are needed to describe motions without any reference to the force, and then the dynamic is about the force. Okay, so this one we can skip it first. So now we are going to look at the difference between distance and displacement. This is a very typical examples in between that shows you the difference in between scalar and vector. Distance is a scalar quantity. Okay, now scalar quantity is always a positive value. We don't have a negative value. Distance cannot be negative, time cannot be negative, so they are always positive. So distance, the SI unit is meter. Okay, we use it to represent total or actual path travel by someone. When it comes to displacement, now displacement is a vector quantity. Okay, so you're looking at the shortest distance. We are going to look at the initial position to final position. Okay, it is a straight line that drawn from initial to final position. In other words, it shows you the shortest distance. So it doesn't represent actual path. So this is the main difference between distance and displacement. Distance is it look at how many meters that you have walked, okay, and then you have to add them up. If you walk that path twice, then you have to calculate it twice. But when it comes to displacement, that is not the case. You're just going to look at the shortest distance between initial and final position. So it is a vector quantity. It can be positive, negative, or zero. Right? So the unit is also in terms of meter. So don't get confused between distance and displacement, because the question can mention calculate the distance between two objects or calculate the displacement traveled by someone. Now let's look at this example. Okay, the example. So a car traveled from A to B, and then from B it went back to C as shown in the diagram above. Determine the distance and the displacement traveled by the car. So again, distance just now we say it represents actual path. Okay, it represents actual path. So it represents actual path means that you have to add the path traveled by this car, regardless of its direction. So you're going to calculate the distance traveled from A to B first. Okay, distance from A to B. Okay, and then distance from B to C plus distance from B to C. So which is equals to now 100 meter plus 40 meter, which is then equals to 140 meter. So that is the distance traveled by the car. Okay, so now another reasons why it is important to know the difference between distance and displacement, because we use distance to calculate speed, whereas we use displacement to calculate velocity. So it's very, very important to know the difference between this scalar and also vector quantity in chapter 2. And then displacement, we're looking at the shortest distance. Okay, the shortest distance. Now, in this case, if you have a diagram, then it is very simple. It is very easy. You just have to look at the diagram. So you want to know this distance, the distance between initial and final position. This is our displacement. Okay, this is our displacement. So the displacement between these two objects, A and C, based on the diagram, okay, displacement equals to 100 meter minus 40 meter, which is equals to 60 meter. So even both of them, they are referring to the same case. One you plus 40 and one you minus 40, because you want the shortest distance between two objects. Now let's assume if this car, it travels back to to point A, okay, it goes back to point A, then what is the displacement? The displacement will become 0. Okay, so let's assume if the car, it travels, okay, it goes back to A, then the distance is now equals to 200 meter. Okay, the distance keep increasing, but then the displacement is 0 because now it goes back to its original position. All right. So that is the main difference between distance and displacement. Okay. So I think that's it. The revision. Next part is a new. Okay, it's a new chapter already. All right. So this is the revision. Make sure you know difference between distance and displacement before we proceed to chapter 2. Because your chapter 2, if I'm not mistaken, it begins with velocity. Okay, velocity. So velocity means that we're going to use displacement. Okay, we're going to use displacement. So if the question asks you about speed, then you have to use distance. All right. So so far, any questions? Any questions? Class, any questions?
No, madam.
No, madam.
No, madam.
No, madam.
All right, good. So if no questions, I think that marks the end of today's class. So it's 55 minutes. You take 5 minutes break before you proceed to next class. All right. So next week we're going to continue with chapter 2. So I will finish chapter 2 next week. Okay. So you may leave the class now.
Thank you, madam.
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 Miss.
Thank you, madam.
Thank you, miss.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.